Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle, and it's called Marble Hodgepodge by Nicholas Duhale. And actually we've been doing a decent amount of Nicholas puzzles, so they seem to, they interest me essentially, so it's been pretty cool. Here are the rules. Place the digits 1 through 9 in each row, column, and region. In each row, column, and region. Regions are orthogonally connected and have to be determined. Some region borders are given. So this is actually chaos construction rules. And we have to construct the regions such that there are 9 cells in each region, and they must be orthogonally connected to the regions must be orthogonally connected. And what that means is that if you take any cell in a region, you can traverse to any other cell in that region just by crossing edges. You cannot cross, you could cross corners, but specifically, we can get to any other cell in the region by just crossing edges. So as an example, you could have something like this is valid because to get from here to here, you have to remain in the region by crossing edges, but you can do that this way, right? But this would not be a valid orthogonally connected region because to get to this part, you have actually let's say this is not also a valid one because even though these guys share an edge, if you try to go from here to here, you cannot do that just through this region by going through edges. I hope that's a clear way of explaining what orthogonally connected means, but yeah. We also have a digit in a circle indicates how many of the up to 8 surrounding cells are part of the same region. Not all circles are given. So for example, if this were to be 8, that would mean that all 8 cells are part of the same region as the circle, right? So you would guarantee that this would be a region if this were an 8. If you had, say, something like, actually, let's show the example that we had. I don't even remember. It was something like, I think this. Yeah, we had this as a region. This would say we have 1, 2, and 3 surrounding cells which are part of the same region, right? This would say there's 2 because it's those 2. And it's of the up to 8 surrounding cells, right? So it would be around this circle. So that's how digits in a circle work. Additionally, a digit n within a circle appears in circles n times. So if you had, say, a 3 and a 2 here, there would have to be 3 3s appearing in circles. So you would have to have 2 other 3s in these circles. There would have to be 2 2s in the circles. And that includes this one, obviously. So there would have to be 1 other 2 in the remaining circles. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, let's count how many circles we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Let's just double check, counting this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16, plus 5 is 21. And we know there are at least 5 unique digits in the circles, right? Because these digits cannot have repeats. So it could be, it's at least 5 digits adding up to 21. It could be 6 digits, but we don't know. So it's either 5 or 6 digits adding up to 21. You can never have a 9. So you can never have a 9 in any of the circles, right? Because the digit indicates how many of the up to 8 surrounding cells are part of the same region, right? Um, hmm. You have to have at least 5 digits, so it could be like 1, 2, 3, 7, 8 is possible. Um, how many digits can these cells be? This has to be 1, 2, or 3. This is 1, 2, or 3. This is these 5 by themselves can never add up to 15. This is 1 through 5. This is 1 through 5. This is 1 through 5. We have to have 5 unique digits here, but that doesn't add up. These 5 digits by themselves do not add up to 21 because it has to be the digits 1 through 5, right? This has 5 remaining surrounding digits. This has 5 surrounding digits here. This has 5 surrounding digits. So the remaining digits in column 9 are 6, 7, 8, 9, right? This can't be 8. This can't be 7. So we must have the digits 1 through 6 in the circles. So these must be 1 through 6. But this cannot be 6, this can't be 6, and this can't be 6. This can't be 6, this can't be 6, and this can't be 6. Oh, that's interesting. Right. 6 can never be on the borders. 6 always has to be in the middle. Where can the 6's then be? Well, 6 in column 5 can only be one of these 2 cells. Three, 4, 5, 6, 7, 8. So if this were 6, if this is 6 and this is 6, is that ever possible? Well, I guess, yeah, actually. Hmm. Oh, no. Okay. This can't be 4 or 5. This can't be 4 or 5. The corners can only be 1 through 3, right? What does that mean? Okay, one thing we do know. One of these 5 circles in column 9 must contain a 1. So that means the rest of the circles cannot contain a 1. Right? Because all the 1s are accounted for here. We also know there's a 2 there, but the problem is we don't know where the other 2 is, right? These are separate regions. Okay. 6 has to be 6 out of these 7. Okay. Oh. Where are the 6's in these circles? One of the sixes can be here. One of the sixes can be here. One of the sixes has to be here. That's 3. One of the sixes is here. One of the sixes has to be here. And this has to be a 6 here. So this is guaranteed to be a 6. One of these two is a 6. One of these two is a 6. These 4 have to be 6s. So this is 6, this is 6, this is 6, and this is 6. One of these two is a 6 here. And one of these two is a 6, right? So this can never be 6. This can't be 6, and this can't be 6. Where is the remaining 6 in column 9? It has to be here. So this is a 6. That's saying 6 of the surrounding 8 cells are in the same region. That's interesting. Obviously, if this were a 6, that would not be part of that same region. 6 of the remaining 8 cells are in the same region. So it could be something like that. It could be something like that. That means there's 2 other digits in this region. Well, okay. So either 6 is here, which would force that to be 6, or 6 is here, which would force that to be 6. If this were, okay, so say this was 6 here and 6 here. These would obviously not be in the same region. So 6 out of the remaining 7 would be part of the same region. One of these would have to each be essentially part of this other of one of the regions. So we would know then this would have to be at least this 1, 2, 3, 4, 5, and one of these two. This would be also 1, 2, 3, 4, 5, and one of these two. Right? Because you need 6 out of the 7. This would have to be guaranteed to be these 6, right? So this would be part of this. One of these would extend. This would extend to one of these. So if this were 6 and this were 6, this is how it has to show up, right? It could extend here and here. We have 2 other digits here. This has 2 other digits. This has 2 other digits. So this does seem feasible. It could extend to here. Or it could extend that way. That does seem feasible. What if this were 6 and this were 6? Then you'd have a similar constraint here, right? So this would all be part of this region. This would all be part of this region. Therefore, we know this would all be part of that. So you have similar constraints there. But if we had 6, 6 here, the problem is, how does this work? I guess it could go. This would have to be green. This would have to be... It could be red or yellow. Actually, this could be red also. This would be green, red. We'd have 1, 2, 3, 4, 5, 6, 7, right? This would be a combination of green and red. And this would be red or yellow. Could not be green. That seems fine. This would then be 4. Because you had 4 surrounding cells part of the same region. So that seems fine. Huh. Okay. That's an interesting constraint. Excuse me. Hmm. Huh. Okay. Where are the fives? We have 1 5 here. Um, we could have another 5 here, another 5 here, another 5 here. That seems okay. Hmm. So 1 5 is guaranteed here. That's 2, 3, 4, 5, and 6 possibilities. Oh, that's interesting. So if this is 6, which makes that a 6, where are the 5s? 5 has to be here, one of these, one of these, one of these, one of these, and one of these. Okay. So this would be, again, green. This would be red. This would have to be yellow. Um, this would be guaranteed not to be a 5. This would be 4. Oh, that's interesting. So where would the 5s be? This would have to be 4 because it sees 4 surrounding cells in the same region. Therefore, this would have to be 5 because there's no other place for it in that column, right? And we know if this is 6 and this is 6, we have all the 5s accounted for. 5 has to be in column 5, column 1, column 7, and column 8, and column 9 in the circles. This could not be 5 because it would be surrounding multiple things. This obviously couldn't be 5. None of these could be 4. This couldn't be 6. This couldn't be 6. We have 6 and 5. Okay, so this is all the same region, if that's the case. This is 1, 2, 3. Um, this would have to have. So this is 1, 2, 3. This is 4, 5. We need another 3. So that works, I guess. Um, um, one of these two is a 5. One of these two. Okay, actually. Uh, hmm. This could not be 5 because if this were 5, all of these would be the same. But then we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in that region. So this could not be 5. This has to be a 5. This cannot be 5. This could be 5 here. That's possible. Or this could be 5. That's fine. So 5 could not be here. One of these two is a 5. If this were 5, it would be 5 by itself here as a blue. That seems fine. This could not be separate from pink or orange. It would have to be either part of pink or part of orange because 5 surrounding digits, if this were the separate region, would eliminate 6, this orange 6 or the pink 6. So this is orange or pink. We're not sure which. Because the thing is, there would have to be, if there were 3 regions here, in this surrounding area, there are, what, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And they are not part of each region, right? And that's the surrounding. So we have to have 5 be pink or orange. This has to be either 4 or 5. We don't know about this. That seems fine. Either this is 5 or this is 5. So if this is 5, this would have to be 3. Because they would be the same region. If this is 5, this would have to be 3 for the same region. So 3 could not be in the rest of column 9. So that seems fine. What about the other way? If we tried to go the other way. Say this was a 6 and this was 6. And this would have to be all its own. This would have to be all its own. But this could not be part of this one. Right? Because if it were, you'd have to have at least 1, 2, 3, 4, 5 other digits. And that's already 11 in size. So this would be separate region. This would be blue. This could not be 6 in that case. This could not be 6 in that case. 1, 2, 3, 4. There's a lot of variety of 5s. 1, 2, 3, 4. So this would be at least 4. Could be 5 here. So since this is 5 at most, only one of these two could be. So it could go that way, I guess. This would see at least 3. This could not be 5. If this were 5, that would mean this would be all of these would be part of it. And you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits here. If this were 5, that could not be part of it, right? So, interesting. If you have 6, 6 here, and 6 here, that's 6 remaining here. This is 5. If we tried to make either of these 5, it wouldn't work. This would be then 5, 6, 7, 8, 9, 10 in size. This would be 5, 5, 6, 7, 8, 9, 10 in size, which is not allowed. So neither of these would be 5. Since 5 can't be here, there has to be a 5 here, a 5 here, a 5 here, a 5 here, a 5 here. So this is 5 or 6 no matter what. Therefore, this is 5 or 6. I don't think this can be 5 either way. If this is 6, again, this would be green. This would be red. So that would be 5 here. The 6 would be here surrounding. If this is, that would be 5 here, and the 6 would be here. So this is red-green. This is forcing this to be all 6. This can't be 5 because of the same problem, right? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, if this is a 5. And if this, instead of this being 6, this is 6, this is 6, we'd have the same issue here. This would be pink, orange, this would have to be blue, and then this can't be 5 and this can't be 5, essentially. This could still be 5 here. Okay. So if this is 6 and this is 6, this has to be all the same region. Wait, hold up. Oh, but this 6 forces this to be a different region, so this cannot be 5 if that's the case. Okay, let's do that. Let's do the choices again. So this is 6, that can't be 6, so actually that could be 6 here, 6 here. Can it actually be 6 and 6 here is the question. I think so, right? Yeah. Oh, this is interesting. If this is 5, that means this would be part of the same region. This is 6. So this is not part of that region. If this were both part of that region, then this would be 5, which is possible. Huh. So 6 can be with here, or this 6 can be here. If this is 6, obviously that limits things. This can't be 6, this can't be 6, so that's guaranteed to be 6. This is probably then the most likely to lead to a contradiction. This cannot be 5, it's 4, which forces this to be 5. But we have already that, so this can't be 4. This can't be 5 because that's that problem. So this has to be a 5 from the digits remaining. Pink, orange. This can't be 5. So again, you'd have 5 and okay, this cannot be 5 here. This could be 5 here. This is not 5. One of these two is a 5. One of these two is a 5. Well, Huh. Um, this doesn't seem to limit things enough, though. I mean, you could have something like this. Oh, you can't have a square because then this would be 5 and that would be 5, right? 5 remaining digits here, 5 remaining digits here. I'm sorry, surrounding digits. So this can never be a square. Hmm. Say this was a 5 here, right? That means all of these digits are the same. This cannot be part of the same region because it necessarily has to have 5 this way. Actually, it would be... Well, it can't go to there. So it would have to be 1, 2. I guess, no. 1, 2. That would be 5 also. So this would have to be a separate region. Be part of yellow. Make it red here, green here. You have 3 digits. Cannot go here. So this is not part of that. Therefore, this would not be 5. And therefore, this would be 5. This would be 3 because this would all be part of the same region. This could not be 3 here. No 3 here. No 3 here. This would, but this would be 3. Okay, so that's a contradiction there. Therefore, this could not be 5 either. This would then be the 5. This would be a 2, 3, 2, 3 pair. That's interesting. Which would force this to be 1. This can no longer be 1. None of these could be 1. This can't be 5 anymore. Therefore, this is 5, this is 3. So that guarantees that, right? This can't be 3, this can't be 3, this can't be 3. Hmm. Um, uh, if this is not part of this region, these are separate regions. This is at least 6, and this would have to be... Oh, it cannot be 2. So this has to be part of this region, right? If this were not part of this region, we have at least 6. 1, 2, 3. We have exactly 6 that are part of the region. That's 1, 2, 3, 4, 5, 6. This would never be possible then. So this has to be part of this region. You're always going to have... This is 1, 2, 3, 4, 5, 6 at minimum. So this would be 4 then. This would be 2. Um, this, I guess, could be part of dark. We have 1, 2, 3, 4. So we have 1, 2, 3, 4. 2 out of 5 would be 2 out of 3 would be in this region. So 3 out of 4 of these are essentially in the orange. And then 2 out of 3 of these would be in the orange. So that's 7 oranges. Hmm. So if this goes, if it goes this way, this is not part of the same region as this, right? One of these is 2, therefore, and this is 2, therefore this cannot be 2. This has to be 4. Actually, we already knew that. That's already 4 there, right? This is a separate region here. This has to be 4. One of these is 2 or 3. This cannot be 2. This can't be 2. This can't be 2. We have 4 5s now. One of these is 3. This is 3. This is a 3, 4, 5 triplet. This cannot be 3 because it sees at least 4 in the same region. This is red or green. Cannot be yellow. If it goes this way, it has to go here because this is a separate region. Could be yellow, but if this is yellow, that fails too. This is 9 cells. So then this would have to be part of blue. And this would be part of blue. And therefore one of these would be 2. And this would be 2. So this cannot be yellow. Maybe it could be orange or pink. It has to be different than the blue, is basically the point. Right? Because this sees only one of these remaining digits. So I guess it could be yellow, yellow here. No, this can't be yellow. So say we went that way. We would have to continue this way. I don't know. This would be some other region. You almost certainly have to be... I guess it... Well, 1, 2, 3... Actually, yeah, can this ever be pink? Okay, so this is all similar. Can this ever be pink? If this is pink, 5, this is 1, obviously. 2, 3, 4, 5 would be pink, and therefore this would no. So this could not be pink. This would have to be orange also. So this would be orange, this would be orange, and this would be orange. You have 1, 2. You have 4 out of the remaining 6 here is orange. If you had both of these be orange, you require 1 more here. 1 out of these 2. So if you had 2 here, say this was orange. If this was orange, that wouldn't work, right? You have at least 5 remaining ones. This would be 1, 2, 3, 4, 5, 6. These would all be orange, but then this would not have 5 remaining digits in the same region. So this would be its own separate region. It could be blue. I think it would have to be blue, right? So say it was blue that way. 5 of the remaining digits. I don't think that works, right? We have 1, 2. This is not part of it. This is not part of it. So this is its own separate region. I mean, something that way, but then this doesn't work. I think this is leading to a contradiction. Right, because yeah, how does this work? No. Okay, this has to be a separate region. So, but say it went this way? Is that possible? This would be 5, so this would block off this. So, no. If this goes this way, it has to include that. So it has to go this way then. This is its own separate region. Because it cannot be yellow, yellow. Because then neither of these would be 2. Or this one could not be 2, because it would see only one of its neighbors be part of the yellow. But these would be in the same region. This sees 3. This sees 3. And that's not allowed. So it can't go that way. It could go this way, potentially. This one could not go here, but then it would have to go here. And then this would have 3 neighbors. I guess this would be 2. That could work. These would... Yeah, the problem is this is blocked here, right? How does it extend? If it goes this way, so say as it goes this way, right? This cannot be part of orange, as we showed earlier. So this would fail this way, right? And then this can't be a separate region, so that wouldn't work. Okay, so the question is, does this actually map on correctly? Well, we need a 5 here. So this is a 5. This cannot be 5 because that would be yellow. And then this would be 1, 2, 3, 4, 11 in size. This can't be 5, so one of these 2 must be a 5. If one of these 2 is a 5, this can never be 5. How do we know that? Well, if this is 5 and this were 5, right? Well, they would be in the same region, so that's not allowed. Actually, there we go. They would, yeah, this could never be 5 because it would have to be in the same region as these 2, and one of these is a 5. So therefore, this has to be 5. This is 3. This could not be 5 because we have the same problem. So say we had this being blue. This could not be part of the same region. It can't be part of this because so it can't go this way. And if it goes this way, that's 5 surrounding cells, and therefore this would be 5. If it goes this way, that's 5 surrounding cells. If it goes this way, that's 5 surrounding cells. It cannot be part of yellow. We could do something like that, I guess. But this would be 3. And this 5 would force this to be 3 also. Yeah. So, we've proven essentially this can't be 6. We know this is a 6 here then. So one of these two is a 6. This cannot be 6. We know this is part of a one set and this is part of another. This sees at least 1, 2, 3, 4. So this is 3 or 4 or 5. One of these is pink, one of these is orange. We're not sure which is which. So one of these is 6 and one of these is 5. No, this could be less than 5 here. What happens if we have 6 and 6 here then? Okay. So this is green. We have red. All of these are yellow. If this were 5, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One of these two is, remember, is part of orange. So that would not work. So first of all, then, this cannot be 5. Can this be all part of the same region? Maybe. So this is either 5, which would force this to be 3, or this would be 5, and which would force this to be 3 here. So 3 cannot be in the rest of column 9. It has to be one of these 2 digits here. This could be 1. Oh, that's interesting. If this is 6, that means this has to be its own separate region too, right? But obviously if this is 6, then this becomes, again, this is green. This would be red. We'd have a green-red pair. One of them green, one of them red. This has to be yellow. So this could not be 6. This can't be 4 or 5. I don't think. Say this is 4. And sorry, could be 4 or 5, but it can't be orange 4 or 5. If this is orange 4 or 5, that would mean we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. This would be pink, orange, or red. Right? Okay, this cannot be 5. This would be 4, which would force this to be 5. Therefore, this would be part of the same region. This could not be 5. This can't be 5. One of these 3 is a 5 here. One of these 2 is a 5 here. One of these three must... Okay, so this could... It would have to be 4 or 5. This cannot be 5. So this is red or yellow, and this is red or green here. Neither of these could be 4. So this could potentially be 5. If that were the case, this is 5, this is 3, this would have to be 5. Because we need 1, 2, 3. Oh. Right. So we have a contradiction, I guess. So if this is 6, where are the 5s? 5 has to be 1 here, 2 here. This can never be 5. Because we tried to have a 6 here. And if 6 is here, this cannot be 5 because that's 1, 2, 3, 4, 5, 6. If this is, yeah, if this is 6 that way, say this is 6, this has to be 6 that way because, or actually it has to be 6 this way. So this can never be 5 because if that's 5, it would be here. If this is 6 and this were 5, either, yeah, we can't, this can't be 6 with orange because that's too many cells there, right? You'd have 1, 2, 1, 2, 3, 4, 5, 6, 7 at minimum, 8, 9, 10, 11. So this has to be its own separate one of 6. So it'd have to be here. And then we'd have, if this were 5, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, whatever. So we know this can't be 5. One of these is 5. One of these is 5. That's 2. One of these is 5. That's 3. One of these is 5. That's 4. This has to be a 5, which forces this to be 6. Since this is 6, it has to be these blues here. These could be in the same region. This can't be 5. One of these is 5. Here, here, or here. This can't be 5, and this can't be 5. If this is 5, that would mean this is all the same region. This would be 3. But this 5 would have to be 5, and then this would all be the same region, and this would have to be 3. So neither of these can be 5 here. Therefore, this is a 5 here. So this is 5. This can't be 5, that can't be 5 because of that reasoning that we had. Only one of these two can be 3, right? This is 5 or this is 5. We're not sure which. So we know these are boundaries, definitely. We don't know anything about these. If this were 4, it would have to be 1, 2, 3, 4, 5, 6, 7, 8, and 9. That's fine. If this were 4, it would have to be 1, 2, 3, 4, 5, 6, 7, 8. But the problem is, even if this were 9, this area doesn't get out. So this can never be 4. This is 2 or 3 then. If this were blue, this doesn't get out. So this can never be blue. This has to be a separate region then. So it has to get out that way. This could go here as 2. Can it ever be 3? Maybe. and it goes that way. This would then be 1. That's possible. This sees at least 4. So one of these two at least has to be blue. If this is blue, this has to be blue, and therefore this would be 5. This would be 3. If this is 4, it'd be this way, and then this would be 2 or 3, right? So if this is 5, that means all of these would be blue. We'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, and this would be blue. Therefore, this would be 3. If this is 4, we have 1, 2, 3. It cannot go down here. It would have to go here. So either way, this is blue also. And this sees at least 2. So this is, we have a 2, 3, 2, 3 pair in row 9, which eliminates 2 and 3 in the rest of the row. Therefore, this is 4, which makes this a 5. This must be in the same region, so this is all yellow because it must connect it here. This is 2 or 3. This is 4. If it's 4, it has to be part of blue because it can't be part of yellow. So this is blue, which makes this 5 to see all this, and this is 3, which makes this 2. That's correct. This is 2. This is 5. This is 6. This can't be 5 here. This is the last 2, since one of these is 2. This can't be 3. This can't be 5. One of these is 2. This can't be 2. This can't be 4. This has to be 3. This can't be 3 or 5. It can't be 2 because we have a 2 here, and one of these 3 is a 2, so this must be 4. We have 3 4s, so one of these 3 is a 4. We have 2 3s, so one of these 3s is a 3. So this cannot be 2, this can't be 2, and this can't be 2. So this is a boundary. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a boundary. This cannot be 2, because if it's orange, it cannot be 2. If it's another region, it can't be 2. It'd be 1 or 4. So this is 1 or 4. Therefore, these two are the same region, right? Yeah, if that's the case. So if this is 1, it can only be one region here. If this is 4, it's part of orange, and then this would be part of a region, the same region, right? Because it sees 1, 2, 3, 4 cells in the same cell region. But if this is 4 and this is the same region, this cell would see 1, 2, 3, 4, 5, 6. So that's not allowed. So this has to be 1. This is its own region going up. So this is dark. This sees 5 cells, which have to be the same region, so this can't be pink, this is orange. This can't be orange, this is the remaining pink. Therefore, this is a boundary. This is a boundary. This can't be 1, this is 2, this is 4. This sees 2 digits that have to be the same region. This sees 4. Well, the black has to go here, so this must be part of black then, right? The black cannot go elsewhere. It can't be part of pink. Can't be part of orange. This sees 4. So I think it has to go like this then? If it's 2 is not part of it, the problem is 4 would see all of these, and then the 2 is blocked. So the 2 has to be part of it. Since the 2 is part of it, I guess the 3... Okay, if the 3 is not part of it, this has to go here, and then here. And then this 3 would not see 3. So the 3 has to be part of it also. Well, this sees 2 already, so this has to be part of a separate region. So this is dark. This sees 1, 2, 3, 4, 5, 6, 7. So it has to go here. This is 8, and it sees 3. It cannot be here. It has to extend this way. and then it has to extend one more here because this already sees 3. So this sees 4 here. This is the boundary this way. This orange has to go either here or here. We're not sure which. This sees 6, so it sees 5 here, and then it sees 1 more here. So it must see one of these must be yellow. This could be part of this, technically. This has to be its own separate region, so we're going to mark it as gray. This cannot be part of this, so this has to be part of this region. We have 1, 2, 3, 4, 5. We have 3 more here. We're not sure. So 1, 2, 3, 4, 5. You could have 6, 7, 8. You have to have 6, 7, 8 here, which means this must be pink and pink. And therefore, we know that's given because this can't be any other color. Can't be gray because this would be 1, 2, 3, 4, 5, 6, 7 plus 3, 8, 9, 10. Can't be dark. So this must be pink here. 3 are here. We have another one here. We're not sure where it is though. This sees 2. This sees 5. 1 is here, and then one of these is yellow, and the other ones are different colors. So if this is yellow, I guess this could be orange. That could be the case. So these specifically have to be orange and yellow, right? I guess this could be something else. Maybe. We'll make it red. But this specifically has to be yellow and orange. If it's a different one, the yellow would have to block this off. So yellow, orange, or red. This is many things. Orange. Pink. Sorry, not pink. Orange, green, or red, I guess. One of these is yellow, and the rest cannot be yellow. Right, because we have 7 already. One of these must be yellow to get 6 surrounding cells in the same region. This has 6. 1, 2, 3, 4, 5, 6. This has 5. 1, 2, 3, 4, 5. This has 4. 1, 2, 3, 4. This has 3. 1, 2, 3. This has 1, 1. This has 2, 1, 2. This has 3, 1, 2, 3. This has 4, 1, 2, 3, 4. This has 5, 1, 2, 3, 4, 5. This has 6, 1, 2, 3, 4, 5, 6. This has 6, 1, 2, 3, 4, 5, 6. This has 4, 1, 2, 3, 4. This will have 6, but we don't know. This already has 5 here. This cannot be yellow because you just can't extend. So this is red, maybe? Maybe these are part of the same region is kind of the thing. This must be, okay, we need a 5 and 8, 7, 8, and 9 remaining in the dark region. This is 7, 8, and 9. In this region, we need a 1, a 2. 2 cannot be here in the blue region, so this must be 2, which leaves 1, 7, 8, and 9 in the rest of column 8. This has to be 1, 7, 8, 9, so one of these is a 1 here. So none of these could be 1, 2. It could be what? 3, 4, 5, 8, and 9. 5, 7, 8, 9. 3, 4, 5, 7, 8, and 9. But this can't be 5 here, and it can't be 7 here. This can't be 5. This can't be 4. The remaining digits in column 5 are 1, 2, 3, 8, and 9. This can't be 8. This can't be 8 because of this 8. Uh, 5 has to be one of these two digits here. Remaining digits in row 9 are 1, 6, 7, 8, 9. But this can't be 6. This can't be 6 because it's in the yellow region. Can this be a separate region from the red? Okay, say this was 5 here. Obviously, then this would be a separate region. One of these two is green. This can't be red. These three can't be red. Therefore, the remaining digits would have to be red. So this would be red. This would be red. This would then have to be green. This could not be green. It's red or yellow. One of these is yellow. Therefore, this has to be a yellow. So we have 1, 2, 3, 4, 5, 6, 7, 8. One of these would be 9. This could not be yellow, and it can't be green. This would have to be red. Hold up. One thing we know, oops, is this can't be 6. That can't be 6. This can't be 6. This cannot be 6. So 6 has to be one of these two digits here. Okay. So again, if this is 5, that means this is green. All of this is the same region. This cannot be part of that because it has to add itself and 3 other cells. So that would make this 10 if this were the same region. Also, this is 5 and 5. So the remaining digits here would have to be all red. Then this could not be, I don't know. This can't be orange because then this would be orange, right? So this would then have to be not red. This would be orange. This would have to be orange because there's no other place for it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have to be yellow. This would be yellow. So it could not be 6, which would force this to be a 6. So it could not be green. This would have to be part of red. This would have to be part of red. So that's 1, 2, 3, 4, 5, 6, 7, 8. This would also have to be part of red in 3. So far, this is all looking fine. So if this is 5, okay, this would be green. Yeah. This would have to be 3. And therefore, this would be 4. Otherwise, this is not 5, and this would be 5, right? So this is 4, 5 here. Can these be part of the same region is kind of the question. This cannot be 5 then. This would be not 5. This would be 5. So this would be part of the same region. Or I guess this could be the green. Hard to say. Let's make that light. This is 6 and 5. So they each count toward each other's. Actually, are these ever part of separate regions? If this is 6, I think the answer is no, right? I think these have to be part of the same region. Say this was one region. I don't know. Dark here, and this is green. Well, this dark, I guess it would have to be the same as red. So this would have to be the same as red. That would be 5, and you'd have a 6th. So the point is no, because then this is a separate region, but it would only be 1, which is not possible. So these are part of the same region. What is this at least then? We have... It could be that this is technically green, quote unquote. So it's 1, 2, 3. This is at least 4. So this is at least 4 also. We have a 4, 5, 4, 5 pair in column not 1, which eliminates 4 and 5 in the rest of the column. Therefore, this is 3. These are part of the same region. Can this ever be can this ever be red then? Is the question. Or can this essentially be green? This is already 2, 3. Say it shares there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. This is 5. It technically could be, right? It's a little problematic. Oh, wait, no. Okay, it can't be. Maybe it could be like. I guess it could be 1, 2, 3, 4, 5, 6, 7. This would then be 4. That's the case. That would see 4. Oh. The problem, okay, so the problem if this is the same region, though, is it blocks off. It can't include all of these digits, and yellow can't. Yellow only takes one of these. And green, if these are the same region, then they would essentially take up, at most, 4 cells here. And that would leave at least 3 cells here, which would be blocked off from another region. So this has to be separate regions then. This is green, this is red. This cannot be a separate region from green. If this were a separate region, then this would have to be 4, and this would block off this region. So this is green. This is not part of the 5, right? So I think these have to be part of the region because at least one of these must be green, right? This is not green because of how we showed like this doesn't form a region by itself here down here, and this would block off that region from getting to 9. And the green region could not contain all of that, this sub-region here. Yellow, obviously only one of these is yellow. Therefore, this is separate from this is separate from that. Well, we only have 6 spaces left, and one of these 2 must be a green, right? Because this is not a green space, so that's 7 spaces left here. So it has to be all of these, and it can be at most, it has to have at least 1 green here. Since one of these is green, the rest must be red. So this must be then red. This can't be red anymore. This can't be orange. Therefore, the yellow orange has to be both of these spots. So this is orange, this is orange. So this is guaranteed. Because there's no other place for the orange. This can't be 7 then. 2 has to be one of these two. We're not sure which. This can't be 7. This must continue on to here as the last yellow. So this is that region. This all must be green. And this is a green-red combination here. The green cannot go any further here. Oh, this can't be 6. Therefore, this is a 6 and cannot be green. So it must be part of red. This is the end of a region here. So this must be part of red also. Since these are red, this must be a red because it can't be green anymore. So this is red, which means this can't be green. Or sorry, this can't be red. We have 3 reds here. Therefore, this is green, and this must be 5, and this must be 4. This can no longer be green because we have already 6 green surrounding cells here. Therefore, this is 5. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this red region is all done. This has 4, which must be light, but we don't know where. This cannot be green. It has to be light because of the medium can't extend there. So this is light. Green can extend to here, or to here. Gray has 3 surrounding and then 1 extra because it has 5 here. So it could extend to any of these. Could be medium gray. And light, this cannot be, so this is 8, I think, right? I guess the light could be something like this. So light could go here too. So light can be any of these technically, right? This sees 4, so we know, okay, so this medium can only get to 1 extra here. This can't be 2. So 3 cannot be here, 3 cannot be here. Where's the 3 for the yellow? It has to be here. One of these is 4. So it's 1, 4, 7, 8, 9, 1, 4, 7, 8, 9, and one of these must be 4, so therefore this can't be 4, can't be 2. It's 1, 7, 8, 9 here. This is 1, 2, 4, 7, 8, 9, but 7 cannot be here because of that 7. Remaining digits in column 1 are 1, 2, 7, 8, 9, but this can't be 2 here. 1, 2, 7, 8, 9. 1, 2, 7, 8, 9. 1, 2, 7, 8, 9. This can't be 1. 3 has to be one of these 2 digits because this can't be 3. This can't be 3. So 3 is one of these 2, which means this cannot be 3. 2 has to be one of these 2. So this can't be 2. For the orange, therefore one of these is 2, so this can't be 2 here. For the pink, one of these is 2, one of these is 2. For the red and the orange, therefore this cannot be 2 here. This can't be 3 anymore, and this can't be 1. One of these 2 is 3 here. One of these is 3. We have 1, 2, 4, 7, 8, and 9 here. That's fine. This can't be 7 because it's in the orange region, which has that. This is 1, 2, 3, 4, 8, 9. If this were green, say this was green, it has to go 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have to be light because it could not be medium, but this light would have to go here, and this would no longer have 6 surrounding it that are medium. It would have 1, 2, 3, 4, 5. So this cannot be green if that's the case. If this were green, you'd have 1, 2, 3, 4, 5, 6, 7, 8. That would be 9, actually. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would have to be light, but then this would have no way of getting through, so this cannot be green either. Can this actually ever be light? Maybe. If this were light, this would have to be green, green here. This would be light. You would have light, 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 light. But then this would be 5 mediums here. So this can never be light. This is green. So one of these 3 is green. We're not sure which. We need a 1. What are the remaining digits in row 5? 2, 3, 4, 7, 8, 9. One of these 3 digits is a 2. One of these 2 digits is a 2 for orange. And we have a 2 for red here in rows 6 and 7. So the rest of row 6 and 7 cannot contain a 2. Where is the 7 in the red region? It has to be in rows 7, 8, and 9. In the yellow region, it's rows 8 and 9. And in the blue region, it's rows 7, 8. So the rest of rows 7, 8, and 9 cannot contain a 7. So this can't be 7 here. Remaining digits in column 6 are a lot. 1, 2, 3, 4, 5, 7, 8, and 9. This can't be 4 because of the 4 in the region. None of these can be 2 because one of these has to be 2. This can't be 2 either. So only one of these cells is green. Only one of these cells can be medium gray. So at least one of these cells is light, but that doesn't tell us very much. Okay, where's the 4 in the pink region? 4 can no longer be here, 4 can't be here, 4 can't be here, it has to be here. So this is 4, which means 4 cannot be here. Oh, this can't be 4. Where's the 4 in the yellow? It must be here, right? So these can't be 4 now. Where's the 4 in the red region? It has to be here. So this is 4. This 2 means this has to be 2. This cannot be 4. This can't be 4. This can't be 4. Where's the 4 in the orange region? It must be here. So this is 4. We no longer have... So green cannot have a 4 here. 4 cannot be here, 4 can't be here, 4 can't be here. Where's the 4 in the green region? It has to be here. One of these two must be a 2, so this cannot be a 2 here. Where else do we have? This cannot be 1, 8, or 9. If this is 1, 8, or 9, all of these 4 digits would see that digit. And therefore, this would be a 1, 2, 8, 9 quadruplet, which eliminates 1, 8, 9. So this cannot be 1, 8, 9. This must be a 7, which means this can't be 7. These can't be 7. This can no longer be 7. One of these is a 1, because this can't be 1. So the rest of the orange region cannot have a 1. One of these 3 pink cells is a 5. Therefore, this cannot be 5. I think we have all the 4s now, right? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. 6s. We actually know where the last 6 is because we have 8, right? 1, 2, 3, 4, 5, 6, 7, 8. This has to be a 6, which means this cannot be dark or medium. This has to be light. So that means this is 1, 2, 3, 4. 1, 2, 3 here. These have to be all medium. So we have, this has to be light then to connect the lights. This is a boundary. Remaining digits in row 1 are 1, 7, 8, 9. But this 8 means this can't be 8. Two out of 3 of these cells are light. But if this is green, how does this light get to 9? It can't. 1, 2, 3, 4, 5, 6, 7, 8. So this cannot be green. This has to be light. We have 1, 2, 3, 4, 5, 6, 7. It cannot be 8 and 9. So one of these is medium, one of these is light. Therefore, we have all the mediums that we need. We need another light. We have 1, 2, 3, 4, 5, 6, 7, and one of these, 8. So this must be a light, which means this is green. So we have this area as a boundary. This is a boundary. We don't know which of these two. Remaining digits in row 2 are 1, 2, 3. This can't be 7. And 5, 8, 9. But this can't be 8. This can't be 5. Okay. This cannot be 8 because of this 8. These can't be 8 because of the 8 in the column. Remaining digits are 1, 2, 3, 5, 7, 9 in column 2. 1, 2, 3, 7, 8, 9 in column 3. And 1, 2, 3, 5, 7, 8, 9 in column 4. But neither of these can be 2 because of the 2 in the red region. This can't be 5 because we already have a green 5. Therefore, where is the 5 in column 4? Cannot be any of these because they all have a 5 in their region. Can't be here because one of these two must be a 5. So this must be a 5 here, which means none of these two can be 5. Therefore, for the pink region, this has to be a 5. Also, this has to be 3 here. Okay, this 8 means this can't be 8, so this is 9. Which means this can't be 9. This is 3. This can't be 3 or 9 here. This can't be 8. This must be 1. Which means none of these could be 1. This can't be 9 because of this 9, so this is 2. Which means neither of these are 2. This can't be 1, 2, 3, 7, 8, or 9, so this is 7. Which means in the medium gray region, this can't be 7. These can't be 7. These can't be 7. We have an 8, 9 pair, which eliminates 8 and 9 in the rest of column 5. This can't be 8 or 9. This is 1, which means this can't be 1. This can't be 1 here. We know we need a 1 then for the light region here, which eliminates 1 in the rest of the light region. So this can't be 1 here. We need a 5. Actually, I think we have 8 5s too. Oh, yeah. Well, this can't be 5, so this has to be a 5 here. These can't be 9 anymore. We have 8 5s. We know where the last 5 has to be. It has to be here. This can't be 5. This can't be 3 because of the 3 in the column. Therefore, where's the 3 in row 6? It must be here. Where's the 2 in the orange region? It must be here. This 9 means this can't be 9, and this can't be 9. We have a 1, 8 pair in the orange region, which eliminates 1 and 8 in the rest of the region. Therefore, this can't be 8. This must be 9. That makes this 8, which makes that 1, which makes that 8. This 8 makes that a 7. This 7 and 8 makes this a 9. This can't be 8 or 9. What's a 1, 7 pair? This 7 eliminates that 7, so this is 8, which makes this a 9. This can no longer be 9. This can't be 9. This can't be 9. This can't be 8. So it's a 1, 7 pair here, which eliminates 1 and 7 in the rest of the light region. Where is this? Well, no. This can't be 8 because of the 8 in the row. So this is 9. This is 8. This 9 and 8 eliminates 8 and 9 here. So this is 2. This can't be 2, 8, and 9. So this is 3. This can't be 1, 3. Sorry, this can't be 3, 7, 8, 9, which makes that a 1. Therefore, this can't be 1. This can't be 2. This can't be 2. We have an 8, 9, 8, 9 pair in column 1, which eliminates 8 and 9 in the rest of the column. So this has to be a 7, which makes that a 1, which makes that a 7. These can't be 7 anymore. These can't be 8. We have a 2, 3, 9 triplet in the green region, which eliminates 2, 3, and 9 in the rest of the region. Therefore, this is an 8. This is a 9. That can't be 9 here. This 3 means this can't be 3, so this is 8, which means this can't be 8. Therefore, this cannot be the medium region because we already have an 8 in the medium region. Therefore, this is light. This can't be light because of the 4 surrounding cells, which must be in the same region. Therefore, we know what this is. This cannot be 3 here. This can't be 3, so this is 2, which makes that 3. This 2 eliminates that 2, so this is 9, which makes that 3, which makes that a 2. These can't be 7. It's a 1, 9 pair. This can't be 1, 8, or 9, so this is 2. This can't be 1, 2, or 9, or 8, so this has to be 7, which makes that 1, which makes that 7. This 1, 9 pair in the red region eliminates 1 and 9 in the rest of the regions, so this can't be 1 or 9, so this is 8. This can't be 8 or 9, so this is 1, which makes that 9, which makes that a 1. This can't be 1, 7, or 8, so this must be 9. This can't be 1, 8, or 9, so this must be 7. This can't be 7 or 9 or 1, so this must be 8. Woo! That was pretty hard, I will say. Interesting. Yeah, this rule set is interesting with the surrounding cells being in the same region. There's some interesting interactions here. Yeah. I'm not sure that right now I can generalize it because this is the first time I've ran into this one. But yeah, pretty cool puzzle. Definitely hard. Not very hard, but hard. Um, but the logic was, findable, shall we say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.